In this example, I've got a composite beam that's made of steel. That's piece A, and piece B is made of brass. Okay, and I have Young's moduli of 200 and 100 gigapascal. Okay, and if I know that the allowable bending stress in the steel is 180 and 60 in the brass, I want to figure out what kind of moment I can apply to this beam. Okay, so again, I'm going to transform this into all brass. Okay, so brass, that width is going to stay at 175. I have to make the steel portion wider if I'm going to transform it into brass so that it again can hold the same amount of load. So I get a shape that looks like this. And what I need to do is, first thing I need to do is figure out that N value, okay, which is 2, which means that the width of the steel portion, okay, when I transform it to brass, has to be twice as big, so 350 millimeters. Once I know that, I can calculate the centroid, okay, where the neutral axis is, using a shape like this, and I can find that the centroid from the top is 108.33 millimeters. Once I have that centroid, I can find the moment of inertia about that centroidal axis just using parallel axis theorem as I have here. Okay, 112 BH cubed plus AD squared for each of my rectangles. My original brass and then the transformed steel into brass. Once I have that, I can apply my flexure formula. Okay, first I'll apply it to the brass, okay, whose allowable bending stress is 60 megapascals. Again, C going to the brass is from here down to the bottom. From the neutral axis down is 141.67. Okay, and then divided by I, which I calculated up above. And the moment for that bending stress is 128 kilonewton meters. I do the same thing for the steel. Okay, again, 180 is the allowable bending stress. C now is from here up to where the steel is. Okay, and then this value 2 is because, again, I did that transformation, so I calculate the stress and multiply it times that value. And steel can hold a moment, the steel portion can hold a moment up to 251 kilonewton meters. So the answer we really want is 128. That's the maximum amount that can be applied. If I applied the 251, yeah, the steel would hold, but the brass would not hold. So we take the lesser one here. So again, transform it from the 2 into a single, and then go through and calculating it using that N, which is a ratio of Young's modulus.